Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over our TI83, 84, and 89 tutorials, tips, and tricks for calculus. In this part 3 tutorial, we're going to be going over how to find the x-intercepts or zeros of a function. We're going to be basing our discussion today using a 2007 AP Calculus AB free response question, question 2. That's where we're going to be getting our function from. So considering this graph above, this is the following condition. It states, a particle moves along the x-axis so that its velocity v at time t greater than or equal to 0 is given by v of t equals sine t squared. The graph of v is shown above for 0 less than or equal to t less than or equal to the square root of 5 pi. The position of the particle at time t is x of t, and its position at t equals 0 is x of 0 equals 5. Okay, so we have the graph of the function right here. So the question that we're going to be addressing in this presentation is, at what times is the particle at rest? Okay, so the question is, at what times, could be time or times, is the particle at rest on the interval 0 to root 5 pi. Okay? Alright, so the question now is, what is the velocity of a particle when it is at rest? The velocity of a particle at rest is equal to 0. So if you think about your speedometer in your car, you can look at that as a gauge of the velocity in the positive direction. So if your car reads 0 miles per hour on the speedometer, what does that mean? It means your car is not moving. Okay, so the same idea applies here. When a particle is at rest, the velocity is equal to 0. Alright, so the solution is as follows. The particle is at rest when what? The particle is at rest when the velocity v of t is equal to 0. Okay, so what we're going to do in this problem is want to find the t values where v of t is equal to 0. Okay, so this is the v of t function. So when we're looking for t values where v of t is equal to 0, it's the same thing as finding the x-intercept or the t-intercepts of the v function or the zeros of the v function. Alright, so if you take a look at the graph, we have, this is the first one right here, we can call that t1. This is the second one right here, t2. Third one, t3. Fourth one, t4. Fifth one, t5. And then the last one, of course, t6. Alright, so we already know that v of t is equal to 0 at t equals 0 and t equals root 5 pi. Alright, so we need to find the other times, namely t2, t3, t4, and t5. Those are the other t or t-intercepts that we need to find when the particle is at rest. Okay? Alright, so we're going to be doing this making use of our TI89 calculators and also the TI84. Okay? Now, the procedure I'm going to use here, this is the TI89, is also applicable to the TI89 titanium. It's exactly the same syntax. Okay? Alright, now, what we can do is we can enter this function into the graphing window, and proceed to graph the function and look for the intercepts. But what I'm going to do is I'm going to take a different approach. I'm going to proceed to store this function in the calculator. And then after I'm done storing the function, I'm then going to use the stored function to carry out the graphing of the function. Okay? Alright, so let me show you how to store functions in a graphing calculator. So we want to store sine t squared into v of t. So we just type sine t squared, store that into v of t. Enter. So are we sure if the storage has occurred? Let's go ahead and check. We're going to call up function v of t, and it returns sine t squared. So we've already stored sine t squared in v of t. So the question might be, why are we going through all this headache or problem to go to store the function first before proceeding with the problem? Now, when you're dealing with the free response questions in the AP exam, a lot of times you will be carrying out multiple computations with the same function. Okay? Now, when you store the function, you can do a lot of great things in the calculator without entering the function over and over again, which introduces the possibility of making mistakes when entering the function and also consumes the amount of time which you have a limited time for on the AP exam. So knowing how to store the function is a quick way of just storing the function and just dealing with the symbol that represents the function from there on out. Okay? In this particular problem, we have just one question, which is not necessary to store, but I just want to show you how to store a function so you can form the habit of doing that. Okay? Alright, so we already have the function stored. Now, how do we graph it? Let's go to our Y window. Now, if you notice, the functions here are functions of x. Okay? And if we go back home, this is a function of t. So, check this out. If I enter v of x here, notice what happens. V of x is sine x squared. Okay? So the nice thing about storing this function here is you can do all kinds of things with it, as I said earlier. So if I go to my Y window here, instead of entering v of t, I'll just simply enter v of the independent variable in the graphing window, which is x. Okay, so when I enter v of x, what's stored here is not sine t squared, it's sine x squared. Okay, you always have to change the independent variable to x whenever you're graphing. It's not flexible, it's always x. Okay, so we have that taken care of. Now we're going to go ahead and graph the function. Now if you take a look at the function, the windows are specified for us. You go from -1 to 1 and 0 to root 5 pi. So let's go to the window and specify our boundaries. Okay, so let me just write this down first before we type it in. So the window I'm going to use for the x, I'm going to go from 0 to root 5 pi. Okay, and then for the y, let me just make it a little bit bigger. So I'm going to go from negative 1.01, or let's do 1.05, a little bit bigger. If you use -1, it's fine. I just want to create a little room. Okay, anything close to -1 all the way to positive 1.05. So I just have a little bit of space on the top. Alright, okay, so let's do it. X min, we're starting from 0. X maximum is root 5 pi. I want to make sure I capture the entire graph in the graphing window. Y min is negative 1.05. Y max is 1.05. Enter. And then press mode. Make sure your mode is in radian format. You notice that this is not in degrees, it's in terms of pi or radians. Okay, so we have that entered. So we have the window. Where's my window? There goes the window again. Um, root 5 pi was changed into its decimal equivalent. Um, so let's go ahead and graph the function. Okay, so hit graph. Bam. Alright, so when you're done graphing, always compare what you've graphed with what you have here. Make sure that it's the same. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Basically looks the same. Okay? Alright, so we're looking good. Now we already know the two times when the particle's at rest, 0 and root 5 pi. We need to find this point, this point, this point, and this point. These three x-intercepts, sorry, these four x-intercepts are what we want to find. Okay? So the procedure that we'll apply to the first one will be the same as the second, third, fourth. So hopefully by the time we're approaching the third or fourth determination of the x-intercept, you should have already mastered the procedure. All right? Okay, so we're going to start with T2. Let's write down what we have. We have T1, the first x-intercept is 0. Now we want to find the second x-intercept. So we're going to go to the option F5. F5 is math. It basically carries out different kinds of mathematical computations on the graph. You can find value, we can find 0, min, max, intersection of two graphs, derivatives, integral, point of inflection, distance, tangent line, arc, and you can also shade. Alright, so what are we looking for here? We're looking for x-intercepts. What is another word for x-intercept? 0. Okay? We're looking for 0. Press enter. It asks for the lower bound. What does that mean? It means an x value that's less than the desired x-intercept or 0 that you're looking for. So we're looking for this particular intercept, so pick any x value that's slightly less than it. So 1.7 is good enough. So just a point slightly to the left is a lower bound. Press enter. Upper bound is a point that's slightly bigger than the 0 you're looking for. So just move your cursor a little bit to the right. So you pick a point slightly to the right of the desired x-intercept. Press enter. Okay, and then it tells you what the 0 is. The 0 is 1.77245. We're going to carry our decimal points to 4 decimal places. Remember, the standard for the AP exam is you have to be accurate to 3 decimal places. So we're going to go to 4 decimal places for safety reasons, okay? So T2 is 1.7725. So 1.7725. Okay. All right, now let's find the next one. So we have T2. We want to find the next x-intercept or 0, which is this one right here. Okay, so we're going to repeat the same procedure. Let me clear my window. Now we're going to press F5. What are we looking for? 0. Now we're looking for the value of the 0 right here. Okay, so the lower bound is a point to the left of the desired 0, or a point smaller. Okay, so just go slightly to the left. Don't go way over here because you're going to confuse it. Just go slightly to the left, press enter. Your arrow says that you're looking for the 0 to the right of this arrow. Upper bound, just move your cursor slightly to the right of that 0. Press enter. Bam, and it returns the third 0, which is 2.5066. So T3 is 2.5066 to 4 decimal places. Alrighty? Okay, now we have 2 more to go, T4 and T5. We already know what T6 is, so let's look for T4. So this is the 0 that we're looking for now. Okay. Now to do that, we're just going to follow the same procedure. Press F5, 0. Move your cursor to a point slightly to the left of the desired 0. Press enter. Arrow points towards the right. It asks for the upper bound. Move your cursor to a point slightly to the right of the desired 0. Press enter. And it returns your desired 0, T4, which is 3.070 to 4 decimal places. Okay? So it's 3.07. Yeah, 3.07 is good enough. So we just have to round it up. Okay, now two more. T5. What is T5? Let's look for our next 0, which is this one right here. Following the same procedure. Hopefully you've mastered it by now. We're looking for the 0. This is the 0 we're looking for. So move your cursor slightly to the left of the desired endpoint. 0. Press enter. So the arrow pointing to the right. It asks for the upper bound. Move your cursor slightly to the right of your desired 0. Press enter. And you have 3.5449. 3.5449. So 3.5449. And then the last time is root 5 pi. Okay? In this exact form. So those are basically the times when the particle is at rest. Okay? So let's go ahead and write down the answer. So final answer is the particle is at rest at t equals 0, 1.7725, 2.5066, 3.07, 3.5449, and root 5 pi. Okay, basically the velocity is equal to 0 at these 6 times. 1, 2, 3, 4, 5, 6. Alright, so that's basically how to find the x-intercepts or zeros using the TI89. Now I'm going to carry out the same procedure using the TI84. The syntax here is also applicable to the TI83 calculators. I'm not going to find all 5 zeros, okay? I'm just going to look for the second one. Alright, so let's go to mode first. Make sure we're in radians. We're in radians, good. You don't have the luxury of storing functions here because the TI84 or 83 do not have the computer algebra system inbuilt, okay? Alright, so we just have to enter the function directly here. So we're entering sine. So this one is also a function of x. You have to keep that in mind. So sine x raised to the second power. Okay, so you see here it tells you the different values that this button can assume depending on the mode that you have. So for function mode, it's going to be x. Alright, and then parametric you have t, polar you have theta, and then for series you have n. But we're dealing with functions here, so this button is going to assume the value of x. Alright, so there you have it, sine x squared, press enter. Now let's set up our window parameters so that we have a perfect graph, a perfect snapshot of the entire domain that we want. We want the graph looking something like that. Alright, so our window, where did we put our window? Okay, there it is. For x min is 0, enter, all the way up to x5, which is the square root of 5 pi, enter. Notice it changed it into the decimal representation. Y minimum is negative 1.05, just slightly below the minimum here, so that we have some space. Okay, you could put negative 1, but I like to put some space in there so we can have a nice view of the graph without the graph intersecting the boundaries of our window. Y max slightly above the maximum, which is 1.05. Enter, and then hit graph. Okay, that's basically what we have here. Alright, so want to calculate, let's just calculate this 0 or x-intercept. How do we do that? Now in the TI89 you have this tabs up and above. You don't have that here, so you're just going to look at these buttons to determine the correct button to press. So the trace button right here, if you look above it, you see calculate, so that's what you're going to be working with. Okay, all these buttons in this gray area of the TI84 apply to the graph. Just forget about the functions. Okay. All right. So trace, second function trace will take us to the calculate menu. If you look at this one, is equivalent to the F5. Ooh, snap! What I did. Let's go back to the graph. So if you press F5 here, is equivalent to the calculate button here. Okay. What are we looking for? We're looking for the x-intercept or the 0 as we indicated earlier. So press enter. It asks you the same question. What is the left bound? So move your spider or cursor to a point to the left of the desired 0. Press enter. You see that arrow pointing to the right? It's telling you that you're looking for the 0 that's to the right of this arrow. Okay. As for the right bounds, move your cursor. A nice little spider to the right. Press enter. Okay. So it asks you that it shows you that you're finding the 0 between these two arrows, and it says guess. Guess is another nice way of specifying the exact 0 you're looking for. So what do you do with this guess option? Just move your cursor or your nice little spider to the 0 that you want to compute. Okay, notice that you didn't have that function here, functionality in TI89, just the upper and lower bound. But for the 84, you have left upper bound, lower bound, and the guess option, which helps you zero in on the desired 0 that you are looking for. Okay, press enter, and you have 1.7725 to 2 decimal places, and that's exactly what we have here. Alright, so just basically repeat the same procedure over and over again in order to determine the other 1, 2, 3 zeros of the function. Alright, so that's basically how you find the x-intercepts or zeros using the TI89 and TI84 calculators. Thanks so much for taking the time to watch this presentation. Really appreciate it. If the contents of this tutorial were helpful in helping you determine how to find zeros using your TI84, 83, or 89 calculators, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to other calc tutorials such as this. If you have any questions or comments about the contents of this presentation, just place it in the comment section below and we'll be more than glad to respond. More clips and great support resources for your AP Calc study process can be found at mathgotserved.com. Go ahead and check it out. Thanks again for watching and have a wonderful day. Goodbye.